Chapter 6 in the grade 9 applied math course is looking at what we call recognizing linear relations. And of course we did some of this in the last chapter that you worked on your last assignment, and we're just continuing. As you can see, I'm working at home and I've got Charlie here as my student, and he's trying to distract me. That's what's going on in where I'm at, and I hope that wherever you are, you're more focused than Charlie. So our goal for today is to be able to look at a table of values. And when I say table of values just means, a set of data. And usually a set of data looks something like this. It's in, in a T-chart, right? And you always have the X value listed here and the Y here, and there's a bunch of numbers. Okay? That's when I say table of values, that's what I mean, and you'll see lots of those today. So we want to be able to look at just a table of values and tell if it's linear. Well, before we begin that, we should make sure you remember how to know if something is linear based on a graph. Okay? So imagine we have two relations here. One of them has a straight line, and one of them is a curve. And the question is, which one is linear? And the answer is that relation A is linear. Okay? Linear because it's a straight line. And in grade 9 math, we concern ourselves only with linear relationships, not with these. Grade 10 math, you'll start dealing with some curves, and in grade 11 even more so. But in grade 9, we only deal with straight lines. You gotta get really good at straight lines, everything you can think of. So how do we know? We know the line in relation A is straight. So because it's completely straight, it's linear. Okay, moving on. So what if this is all I had? And this is called a table of values, right? What it tells me is I've got a list of X values, X being what we call a dependent variable, or independent variable, and this is my list of X values, this is my list of Y values, and I want to know if it's a linear relationship. Now, one thing I could do is graph them, because remember, this means I have a data point. Let me just scribble here. This just means I have a data point, 1, 4, and we did a little bit of plotting points, and this is the X value, and this is the Y value. And you could make a graph and see if it's a straight line. That would be one way you could do it. But the other way to do it, the way we're learning today, is using something called first differences. And I have written over here what that means. To find the first differences, you basically subtract consecutive Y values. And what I mean by that, consecutive means one and then the next. So I have to subtract, in this case, you always take the second, subtract the first. So the first difference here would be 7 minus 4, which equals 3. And then if I did the first difference right here, it would be 10 minus 7. And that's 3. So basically what it means is the Y value is going up by the same number every time. This one's 13 minus 10. Okay, so you look at two consecutive, one then the other, Y values. You subtract the lower, you take the lower one, you subtract the one above it, 13 minus 10. And if these numbers are all the same, then it's linear. And this is called the first differences. And the only thing that's important to keep in mind is that, in this case, the X goes up by 1, 2, 3, 4. So it goes up by, this time, place 1 every time. Even if it went up by 2s every time, it'd be okay. But say the numbers were, and you don't write this down, please, but say it was 1 and then 4 and then 5 and then 12. See how it kind of goes up by different numbers? Then you couldn't use first differences. You only use them when that goes up by 1s or 2s or 3s or whatever. Okay, and again, don't write that down. It's just to make my point. And that's not something you need to concern yourself with too much in this course. Okay, so there we are. We have a set of data. We calculate the first differences. And if they're the same number, constants, always 3 or always 4, then it's a linear relation. So let's just look at a little example of that again. Is it a linear relationship between Ferd and the number of CDs he buys each week? So here, for example, see it goes up by 2s, 2, 4, 6, 8, 10. So it goes up by 2s, and that's okay. This is my x, remember? The first number written is always the x. The second one is the y, okay? Independent, dependent. And it goes up by 2s every time, so it's okay. We can do first differences. And so all you do is you say, okay, between these two, you go 11 minus 8. And again, it's 3. 14 minus 11. And so on. Pretty much if you do it for about 2-3 sets of data, you don't need to do it for every single set in the table. If it works, basically if it works for 2, it's going to work for them all. But for the sake of argument, we'll do it for every one. So, yes, it's linear because my first differences are constant. Okay? Okay, let's see if this is linear. So again, I have a list of some puppy who's gaining mass. This must be kilograms or something. And this is months. So again, it's going up by constant, 1, 2, 3, 4, 5, the same number every time. So my x value goes, and here's my y value if I was going to make a graph. And is this a linear relationship? Same thing. Do first differences. So this will be between these two. 3, oopsie, minus 3.2 equals 0.3. Okay, these two, 3.8, take away 3.5. This looks linear to me. 0.3. Okay, so I'll do one more, but once you've done it, basically once you've done it twice and it's the same, almost for sure it'll be the same all the way down, but for the sake of argument, we'll do one more. I might as well finish the table, but in this one. So because first differences are constant, this is a linear relationship. Well, I better show you an example where it's not constant, right? So that one's done. We have we have a linear relationship. Let's just put a check mark. Yes. All right, next. This time, this is year. I don't know what the data, this is sort of a generic thing, but again, it's year. Let's pretend this means, that's my X, that's my Y, year from right now and how much money's in my bank account. So say I deposit $100 and then it goes up using interest probably every single month. And of course, why the data is like that isn't really our concern. The question is it linear? So let's just see. Do my first differences. 107 minus 100 equals 7. All right, next one, 114.49. You can tell already it's not going to be the same, right? Because there's decimals. So right there, it's not a linear relationship. Now, we could do one more, just to say. I did this one. So we know right away it's not linear because I have two different numbers. Again, we could do one more because sometimes it could be, it could be approximately linear if it's close, but let's just do this one, see if it's back onto 7. 122.50. I'm going to do this in my head, but you could use your calculator if you wanted to. So it's going to be $6.01. Clearly not the same, right? So I don't have to go any further. I have three numbers that aren't the same. This is not linear. Okay, and that's how you know. Okay, so the next thing I want you to do, you've turned the page on your note, you're going to see this right there. I want you to turn off the video and identify which of these relationships are linear. And this is all this whole note, this whole package I'm going to collect. So I'm going to look how well you copied your notes. I'm going to look at all the assignment questions. So if it says assignment and a little number here, that means that you have to do it on your own without me. So where we'll pick up again, just if you're not sure, the next thing we're going to do together is this. So in the next video you're going to see is going to start right here. So I want you to fill in your handout until you get to this point and then turn on the next video.